All right, we're back. We're actually on to chapter 2, section 2.1, solving linear equations and inequalities. Our essential question, how can I solve linear equations and inequalities? Please write that down. So today we threw in a little note talking about, well, who actually can use this? And if you, yeah, sometimes we do that. A hot air balloonist can use linear equations to calculate the average speed needed to set a world record. So if you want to be a hot air balloonist, you just may use this. Now we have some vocabulary in this lesson. We're just going to go through it quick. An equation, we've kind of talked about this, is a mathematical statement that two expressions are equivalent.
So they have an equal sign.
Correct. The solution set of an equation is the value or values of the variable that make it true.
So your answers.
Yep. And a linear equation in one variable can be written in the form ax equals b, where a and b are constants, and a cannot equal 0.
Okay, we'll kind of talk about
We'll talk about that more. All right, so we're going to talk about some steps because we're going to be solving linear equations. Solving a linear equation requires isolating the variables on one side of the equation by using the properties of equality.
Okay, so what you're saying is you want to get the letter by itself.
Correct.
Okay.
Yep. And to isolate the variable,
or get the letter by itself.
Right, we're going to perform the inverse or opposite of every operation.
Okay.
So just
if
remember
it's
opposite.
adding,
You subtract.
If it's multiply,
you divide.
Okay.
Now, one more thing I want to point out. You're going to do your inverse operations in the reverse order of what you're used to. We're used to PEMDAS.
Yeah.
So when you're solving a linear equation, you're actually going to be doing it in backwards order.
That's not a P. Here we go. So PEMDAS backwards.
When you're solving a linear equation. So the adding and subtracting are going to come before the multiplying and dividing. That is so important to remember.
Okay.
Next page, we will see. If there are variables on both sides of the equation, so 2x plus 3x.
Okay.
What is that, Miss Boyd?
Well, 2x plus 3x is 5x.
Right, so you're going to simplify that, then put the x on its one side by itself.
Okay, so you want to combine all your like terms first and then move things.
Correct.
Okay.
So here's some examples. We're going to talk about linear equations and non-linear equations. So Miss Boyd, I'm going to let you talk a little bit about that.
Yeah, so linear equations basically mean it's going to make a line if we were to plot the points.
Yep.
So here we have 4x equals 8. The one that I like the best is just y equals something. So y equals 4x plus 2.
Correct.
You notice there's no exponent on the x. We always know it's 1 if it's not there.
Right.
But it's just 1. So that means it's linear. Here in nonlinear, it means you're not going to have a straight line if you plot the points.
Correct.
So another one that I like then is y equals like say 5x squared minus 2 or something.
Right.
That's squared.
That is
means it's not going to be a straight line.
Right.
And we'll get more
into that
too.
way down the road.
Okay.
Here, we talked about solving. Let's right now do example 1 and let's solve a linear equation.
Okay. So you told me to do PEMDAS backwards. But I noticed there are parentheses, so we have to do that first.
You know, yeah, and well, I should have actually emphasized that more. We want to simplify each side first, and then do PEMDAS backwards. Yes.
So I'm going to distribute that -3.
Right.
So I get -15 plus, because it's a negative times a negative.
Correct.
12r equals -9.
Right.
Okay, so now you said do PEMDAS backwards.
Right.
I can't combine anything here.
Yep.
So I'm first going to get rid of this.
Right, and we're going to do the
15.
So we're going to do the opposite of
Opposite
that.
is adding.
So right now we are doing PEMDAS backwards.
Okay. So I'm left with 12r
equals 6.
6.
Now we can divide both sides.
Okay, so divide by 12. Divide by 12. R does not equal 2. A lot of you will do that, but this reduces to 1/2.
And there's our answer.
All right.
So thank you, Miss Boyd. So I want to make sure I emphasize that. Do not do the backwards PEMDAS until both sides are simplified.
Okay.
Then, all right? We're going to do example 2 in class.
Yes.
Example 3, we're back to our favorite Miss Boyd and I
Word
love word
problems.
problems. So I'm going to start reading the word problem.
Okay, I'm going to highlight some key things.
The local phone company charges $12.95 a month.
Okay, so no matter what, you have to pay that.
When you make 200, you're the first 200 minutes.
Okay,
So 200 minutes, you pay $12.95 no matter what.
got it.
But you're going to also pay 7 cents for each additional minute over the 200.
Okay,
That's what that means.
got it.
So if Nina's bill for the month was $14.56, how many additional minutes did she use?
Because it's over that $12.95.
Correct.
Okay.
So let's start with our variable. How about we use
Okay.
M? M is equal to the number of minutes over 200.
Okay. Because no matter what, you're going to use 200.
Right. So
Over 200.
Miss Boyd's going to write some things now before we plug in numbers. So what we're going to do is we're going to start with monthly charge.
Because you have to pay that no matter
Yep.
what.
So that's first.
Okay.
And we're going to add to that the additional, I'm going to call it the additional minute charge. Let's call it.
Okay.
Times the number of additional minutes.
Oh,
So over the number of minutes over 200. And
Okay.
that is going to equal the total charge.
That makes sense.
So now we can plug the numbers in.
Okay.
We know our monthly charge is $12.95.
Okay. We have to pay that no matter
Right.
what.
We know the additional minute charge, it says, is 7 cents, so 0.07.
Okay.
And we're multiplying that by M, because we
The number
don't
of minutes
know.
over
Right,
200.
we don't know how many there are over, but we do know our total charge, which is $14.56.
$14.56.
We have an equation.
Oh, that's easy enough.
So let's solve. Right now, we can't simplify the
Nope.
left or the right. So subtract
first.
$12.95 from both sides. And you're going to probably need your calculators out
Yeah, I
here.
can't do that.
And you
Okay.
get $1.61 is
Okay.
equal to, and then the 7, right. Divide both sides by 0.07.
All right.
And after we divide both sides by 0.07, we are going to get 23.
All right. So that cancels. So I left with M. So
Mhm.
M equals 23.
Yep, and that's it.
Oh, that's easy enough.
So example 4, we're going to do in class. We also are going to do example 5 in class.
Okay.
So now we're going to go down and we're going to talk about a different type of an equation. We have solved equations that have a single solution. There are equations that can have infinitely many solutions or no solution.
Okay.
For example, if your final answer is 3 equals 3, that's a true statement, like x equals x.
Okay.
Your answer would be all real numbers because it's a true statement. X disappears, it cancels in the equation, so x is no longer a variable.
Okay.
Or it is a variable, but no longer a variable in the equation. A contradiction, 3 equals 5. That is a statement that is false.
Not true.
And that means no solution. Okay.
All right.
Let's do example 6.
Okay.
So step 1, simplify each side.
Okay.
So we're going to distribute the 2.
So I get 2x minus 12 equals, I look for my like terms.
Oh, we can combine. So that would be 2x
2x
minus,
oh, not plus, minus 12.
right. So,
Yay! It's
you-
the exact same thing on both sides.
right. So you could actually, some of you may right away may not notice that
Yeah.
it's the same on both
So then
sides.
solve it.
So then if we decided to solve it, what would we do?
Well, I'd add 12 to
Sure.
both sides. So those cancel.
Right.
Those cancel. So
And then
I'm
you
left
get 2x
2x
equals
equals
2x, right? And there, you know, yes, let me rephrase. There still is an x in our equation. Remember I said the x will disappear. A lot of times it will,
if
but it
it's
doesn't
the
matter.
same.
It's still a true statement. X is equal to x, so all real numbers.
All right. Awesome.
So example number 7, are we gonna skip?
We can do it quick.
All right, let's do it. So we're gonna simplify both sides. So look at the left side right away. We can combine 3v and negative 4v which is negative
Negative
1v or negative v minus 9, and set that equal to, let's distribute the minus sign right away.
Yeah, so we don't forget.
Yeah, negative 5 minus v. So now we should put the variables on one side and the constants on the other.
Okay.
So I always like to put the variables on the left
So do
side.
I.
So let's do that.
So I'm going to move the 9 then. So
Right.
I'm going to add 9 to both sides then. And when I do that, I get negative 1v
Yep.
equals, well, that makes 4 minus
Yes.
v.
Okay, so now we got to add that v and bring it over to the left side. Well, 1v plus v, that's just 0, equals 4.
4.
That
not a
is,
true statement.
we should draw a line right through that equal sign because that is not a true statement.
No.
And so therefore no solution. So if you get a true statement,
Solution.
x equals x, 3 equals 3, 4 equals 4, that is all real numbers.
Okay.
Otherwise it's a no solution.
Okay.
Okay, now we've talked about equalities, equations. Now we're going to skip over to inequalities. An inequality has the symbols which are shown. Less than, greater than, less than or equal to, greater than or equal to, or not equal to.
Okay.
The graph of an inequality, that is the solution set.
Okay.
The set of all points on the number line that satisfy the inequalities.
Okay.
The properties of inequality, the properties of equality are true for inequalities.
Okay.
But the key thing is there's one important difference.
This is super important, so you might want to star it.
When you are solving an inequality, if you multiply or divide by a negative number, you must flip the inequality.
So if it was less than and you divided by a negative 2, you're going to change it to greater than.
Correct.
Okay.
So we are now going to do example number 8.
Okay.
The same rules apply here.
Yeah, so
we just have an
still
inequality.
Simplify.
Yeah.
We're good. So
Let's-
we're going to move stuff now.
I say let's move the A's to the left side.
Yep.
So you're going to do
So
what
I'm going
first?
to add 2.
Okay.
And we're left with 8a is less than or equal to.
Greater than.
Greater than or equal to. Thank you.
Yep. 13A plus 10. Now we should subtract
Subtracting
13A.
And I'm subtracting 13. I'm not multiplying or dividing by a
Mhm.
negative.
Nope.
So the sign stays the same, greater than or equal to.
And
And now we get
negative
negative
5a.
That cancels and left with 10.
but
Now,
now.
here's the kicker.
Mhm.
Now to get a by itself, I'm going to divide both sides by negative 5. Anytime you divide or multiply by negative 5, you just say, alarm, beep, beep, beep.
Yep.
We got to do something.
You have to flip
So
your.
we're going to have to flip the sign.
Yes.
So instead of greater than or equal to, now we're flipping it to less than or equal to.
Correct.
These cancel. We're left with a. And we get negative 2. And I'm going to rewrite that because that's super
Yes.
sloppy. A is now less than or equal to negative 2. And that is our answer.
That's our answer. But notice what I also wrote.
You said graph.
So let's draw a number line.
Okay. So here's my number line.
And all we need to do is put 1 point, negative 2.
Yep.
But now, Miss Boyd, are we open circle or closed?
Close because we have an equal.
Right.
So I'm going to close it.
And now notice we go to our final answer.
Yes.
And so if we want everything less than or equal to, we're going to go to the
Left.
right. And I call it,
You
if
mean
you,
correct.
did I, what,
You said
oh,
right.
sorry, correct.
Okay.
So would you do me a favor and point
Yes.
to that inequality for me?
Yeah.
I call that the nose
The
pointer
pointer,
at the end.
yeah, it
Mhm.
shows you which
And
way
it
to
says
go.
it's pointing to the left. You can only use that rule though if your variable is on the left
Right.
side.
Correct.
Okay. Correct. Example 8 is done. Let's go on to example 9 and here are your video questions. See you tomorrow.